Hi, chemistry. Today we're going to be predicting acid-base reactions. It's kind of front-loaded with a lot of information, but the general procedure is pretty straightforward. Alright, so when a lot of acids and bases are combined, the predominant reaction is between the strongest acid and strongest base. This is going to look a lot like SOA, SRA stuff. Okay, but I think it's easier. To identify possible acids and bases, we have to know how they appear in solution. So I've created a bit of a chart. Most of it's simple. There's a couple ones that might be harder to keep in mind, and I'll highlight those. Okay, so if you have an ionic compound, it dissociates. I've tried to make that a big deal before the outbreak. So calcium hydrogen carbonate here, you get calcium ions, hydrogen carbonate ions. No big deal. Okay, this one might be new to you. So if you have an oxide, so that's like an O2 minus ion, it'll dissociate, but what happens is the oxide actually ionizes water. Okay, so the water in solution will turn into hydroxide. So you don't actually get oxide in solution, you get hydroxide. So oxide's like a strong base. It ionizes water to form hydroxide. So you'll see that once or twice. Maybe you haven't seen it before, but you'll have to keep it in mind now that oxides ionize water. Okay, so you'll get whatever cation there was plus hydroxide. Strong acids ionize quantitatively, so if you have a strong acid in solution, all you have is H3O. I've written conjugate base here, but we saw yesterday that the conjugate base of a strong acid doesn't change the pH of water. It can't be the strongest base in a solution. So I didn't even write down chloride because it's not going to react in an acid base way. Okay, so if you forget to write or neglect to write a conjugate base of a strong acid, you're fine. Totally okay. If you have a weak acid or a base, which is anything other than those 6 strong acids, oxide or hydroxide, all this stuff, that's what you have in solution. You don't change that. Okay?